Hello everyone, so in today's video we are going to study about all the notes from force and laws of motion, class 9 chapter 2. Now let us begin with the first point. The concept of force is mainly push, hit or pull. Number 2. The force is applied on an object mainly to change its state either from rest to motion or motion to rest. For example, applying accelerator to move a car or applying brake to stop a car. Now, the forces that we have discussed are of two types, valence force and unbalanced force. Valence force, the force which is equal in magnitude but opposite in direction, are called balanced force. For example, if we tie two strings to a brick in opposite side and start pulling it, and if the brick don't change its position and remain in the same state, then it is called balanced. Now, what is unbalanced force? The force which is opposite in direction but not similar in magnitude and tries to move the object in the direction of the larger force, it is known as unbalanced force. For example, two strings X and Y attached to a brick. If X is pulled harder, for example here the X string is pulled harder, brick tries to move towards X direction or X, and if Y is pulled harder, then the brick tends to move towards Y. For example, this case can be explained as the scenario where the winner is chosen for tug of war, where the winning team pulls the losing team towards themselves. Now, what is friction? Friction is an imaginary force which works in a direction opposite to the applied force. For example, you are trying to move a box by pushing, but some kind of power is not letting you push it due to its weight. This invisible power is known as friction or frictional force, which acts in the opposite direction. An object continues to move in uniform velocity when the frictional force and pushing force balance each other, and its speed or velocity starts increasing when you have more pushing force than frictional force. Now we will study about the first law of motion. An object remains in state of rest or of uniform motion in a straight line unless no external force or unbalanced force is applied to the change of state. Number 2. In other words, the tendency of the undisturbed object to stay at rest or keep moving with same velocity is called inertia. So, the first law is also known as law of inertia. Now, to understand this, let me explain it in another example. Now, when we apply a brake to stop a car, we tend to move forward. It happens due to law of inertia, where our body is in motion as we are moving. But applying brakes can make the car suddenly stop. But as we are also moving along with the car, we tend to lean forward due to this. Hence, inertia is basically size dependent. Bigger the size, more is inertia. And mass is used to measure the inertia of an object. Basically, inertia is the tendency of an object to move, and mass is the measure of that tendency. Now we will study about the second law of motion. As we know, the first law tells us about when unbalanced force is applied and bodies changed its state. Let us consider a tennis ball which hits a man, but it doesn't hurt. But when a bullet hits a body, it actually damages the body. Now, why does this happen? This is actually dependent mainly on mass and velocity. And we also know that to accelerate a body, we need to apply more force. Hence, some terms exist between this force, mass and velocity, which actually serves the purpose of hitting a man abruptly or hitting a man slightly. This term was actually introduced by Newton and was called as momentum. Momentum is the product of mass and velocity. That is, P is momentum, M is mass and V is velocity, where the SI unit is kg meter per second. It has both magnitude and direction, and hence it is a vector quantity. Now let us consider a situation where we are pushing a dead car for moving it. Suddenly, if two people give a push to the car, it hardly starts. But gradually pushing over for the some time results in movement of the car. Hence, for this we can say that the force necessary to change momentum of the object depends on the rate of time at which the momentum change. That is, the difference between the initial time when the momentum started to the final point when the momentum changed. Hence, second law of motion states the rate of change of momentum of an object is proportional to applied unbalanced force in the direction of force. Now we will derive mathematically the formulation for second law. For this, let us consider m be the mass of a moving object in a straight line with initial velocity u. It is uniformly accelerated to final velocity v in time t. By application of constant force f through time t, let p1 be the initial momentum and p2 be the final momentum. Therefore, p1 is equal to mu since u is the initial velocity, and p2 is equal to mv since v is the final velocity. Therefore, change in momentum is proportional to p2 minus p1, where we put the values mv and m minus mu and we take common m, so we get mv minus u. Therefore, the rate of change of momentum is directly proportional to m bracket में v minus u by t. Or we know change in momentum is also given by force. Therefore, F is equal to km v minus u by t, where k is the proportionality constant, and as we know v minus u by t is acceleration, so we put F is equal to kma, where m is the mass and a is the acceleration and k is the proportionality constant. Now, the SI unit of mass is kg and acceleration is meter per second square. Hence, force will have the SI unit of kg meter per second square. Now, from the previous part, we have known that F is equal to kma. The unit of force is so chosen that the value of k becomes 1. How? For this, one unit of force is defined as amount that produces 1 meter per second square of acceleration in 1 kg of an object. Therefore, 1 unit of force is equal to k into 1 kg into 1 meter per second square. Therefore, it equals to 1. That is, k is equal to 1. Hence, F is equal to ma. Here the SI unit of kg is meter per second square and is also written as 1 N or 1 Newton. Now, from this we can also determine the first law of motion by using this. But how? Now, let us consider that the body don't change its state. It is either moving or it is either in rest state. So, without any external force applied, its initial and final velocity will be same. Hence, F is equal to m bracket v minus u by t. Now, since initial and final velocity are both same, therefore m bracket in place of v we can write u. Therefore, subtracting u from u will give 0. Hence, F is also 0. Therefore, since F is equal to 0, u is equal to v. For any time t, the object will be in rest if it is in rest, or in motion if it is in motion. The most amazing use of second law of motion can be seen in cricket, where a player pulls down his hand after catching a ball or cricket ball. This is done to reduce the momentum of a ball after catching them so that the players don't hurt their hand after catching them. Okay, now we are going to study about the third law of motion. Definition. When one object exerts force on another object, the second object also exerts some force instantaneously on the first object. This is the third law of motion. This force acts on different object but not the same one. The two forces are called action and reaction, and they are opposite to each other. Now let's understand with an example. Let us connect two balance with each other. One end of the B is kept fixed and the other end is connected to A. When the free end of A is pulled, it is seen that the balance A and B shows the same reading on their scale. It means that force exerted on spring B by A is equal but opposite in direction of the force exerted on A by B. This force which A exerts on B is action and the force which B exerts on A is reaction, and gives the alternative law of motion, that is, every action has equal and opposite reaction. Let us derive an expression for the conservation of momentum. For this, let us consider two objects A and B having mass m1 and m2 and travels in a straight line having initial velocity ua and ub. There is no external force acting between the two bodies or acting on the two bodies. And now let us consider ua to be greater than ub. That is, initial velocity of object A is greater than initial velocity of object B. As a result, they collide with each other. Now, the collision lasted for t seconds and the ball A exerts force AB, FAB on B, and the ball B exerts force FBA on A. Suppose VA and VB be the final velocities of the ball, and A and B after collision looks like this. Here A has initial velocity u1 and B has initial velocity u2. Now when they both collide, A is exerting force FAB on B and B is exerting FBA force on A. As a result of this, they generate two new velocities, where A will having final velocity VA and B will having final velocity VB. The momenta of the ball A before and after collision is m1 ua and m2 va. So the change in momentum, or FAB, that is force, is given by action FAB is equal to m1 va minus ua by t. Similarly, reaction, or FBA, that is force exerted by B on A, is equal to m2 into VB minus UB. Okay, so VB minus UB divided by T. Now, since no external force is acting on the system, so FAB, that is force exerted on B by A, is equal to negative of FBA, that is force exerted by B on A. That is according to third law of motion. Therefore, FAB is equal to minus FBA. Putting this value here, we get, we cancel out T, then we get, by rearranging this equation, we get m1 ua plus m2 ub equals to m1 va plus m2 vv. That is, this part is sum of the momentum before collision and this part is the sum of the momentum after collision. Therefore, from this we can say that when sum of momentum before and after collision is same, it is said that the momentum of the system is conserved. So with this, I end today's lecture. Thanks for watching the video.